Okay, here we go. 63 off of 2.6, right? Let's see. I don't even have it written down. Right down? Anybody got it? F of x. Go ahead. Quick go. Okay, so the first thing you got to do, Caden, is you have to go ahead and factor the top and the bottom to find the zeros. The nice thing about the top is I do not have to do synthetic division because it is factoring by grouping. This is a factor by grouping. That can work. So what does 2x squared and negative x squared have? 2x cubed and negative x squared have in common? X squared. And I'm left with 2x minus 1. Okay, there. Okay, what does negative 2x plus 1 have in common? Negative 1, I'm left with 2x minus 1. So when I factor that out, that's 2x minus 1. And Kate, can you see that x squared minus 1 can be factored out? So I pull that out. What is x squared minus 1? X minus 1, x plus 1. You okay there? So that's what the numerator looks like. And now we go to our denominator. We factor the denominator, and it's going to be x plus 2x plus 1. So we'll do that. Maggie, are you getting factoring? A little bit better? Okay. Everybody understand how I did the top and the bottom? Okay. So I notice this is 2.5 basically, right? Minus the zero, how do I do it? But if you'll recall, if you see here, f of x, notice the x plus 1 cancel, so that becomes our whole. Okay? Okay. So the x plus 1, so notice I'm going to write over here a whole. Okay? Now, here in the graph, I'm going to graph is this guy. So how do you know that whole? Because right to that? Yeah. So the value I could be in this equation, right? Can I be negative 1 in this equation? Yes. In this one I can. In the original one, can I? No. But it's simplified out, so therefore I look like this guy, right? The simplified polynomial rational thing, right? Okay. I look like him, but at the beginning I still can't be the values that I had in my original. So in that case I cannot be negative 2 and negative 1. But notice in this equation I can be negative 1. So that's why I have to put a hole on that graph because it doesn't take into account the vertical asymptote. Okay. So notice, now my hole is at negative 1. How do I find its y value? You plug it into the simplified. 2 times negative 1 is negative 2, minus 1 is negative 3. Negative 1 minus 1 is negative 2, so I have negative 2, negative 3 times negative 2 is 6. Negative 1 plus 2 is 1, so 6 over 1 is 6. So that's the location of my hole. Everybody understand the location part, what I'm saying about that? Okay, so now, my vertical asymptote, where's that at? Well, right there, negative 2. What is my zeros? Or my x-intercept, as they say, right? That would be 1/2 and 1. And then I have my horizontal asymptote slash slant slash oblique. I think in the book they kept calling it slant, right? I think the oblique, just to let you know where my work came from, I think that's pretty much, I just dictate anything past not a horizontal, an oblique. Because I think when it's like, if you ever had to do long anything like this, where you call it that one. why you're off just a little bit and not exactly on 2x minus 7. Because this other stuff I think is really close, but not touching it, right? That's the main difference of why this forces the middle slant. Because of the left right there. Okay? So now, you know here, basically that's all I care about here with 2x minus 7 on the graph. And here's where we go. Okay, so notice I have 2x minus 7. 1, 2, 3, 4, 5, 6, 7. Up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. That's my slant slash oblique, right? What was my vertical again? Everybody tell me what the negative was. And then my zeros were at 1 and negative at half, or positive at half, right? 1 and then positive at half. How do I know I got it? Remember, it's going back to graph the line and start at y-intercept, y-intercept. Oh. Hey, you guys ready? Is that all my info? Oh. Okay. So, now I start taking some information, right? A number greater than 1. What was my thing over here? I think it was 2x plus 1, x plus 1, and, or these are minuses, right? X plus 2. Okay, we all ready? Okay, we ready for our chart? Cody, you ready for our chart? Yep. Outside, Cody, are you ready for our chart? Here we go. Number greater than 1. Million. Positive, positive, positive gives you what? Positive. So therefore, these guys give us a million. That. Is this guy even or odd multiplicity? Odd. What do you guys think this one is? Cross. So let's pick a number between a half and what? 0.75. 2 times 0.75 still positive. Negative. Positive. So we got one negative, two positives, that is a negative. And that's what we just said. It should be crossed, right? And you already got to come back up to that 0. I don't know how well it goes, and I don't care. Okay. And then at a half, pick a number less than a half, 0. Okay, that becomes negative, negative, positive, which is a everybody good there? It might get deeper into here, I'm not sure. I don't care. I'm not graphing accurately, right? Huh? Nope. And then now I got to pick a number less than negative 2, which is negative, 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 which is negative 3. That make sense? Yeah. Guys, right there, that would be one page of your test. But I'm saying, that's basically just one problem. But notice I'm breaking that problem up into separate problems. Like I'm going to say, find your verse graph. You know what I mean? And then what are you going to do? Remember how we did it last time? It's going to be kind of like, okay? Does that make sense? How we break it down and then go at it? Okay. Piece by piece, right? Eating an elephant, day by day. The nuts, or bite by bite, or whatever the heck they say. Anyone else? Lemon? So 2.7 is going to give you an idea of what's going to happen in doing 2.5 and 2.6 all over again, except we don't have to graph. You still got to find the vertical asymptotes, you still got to find the zeros, just like we did in both sections, correct? But then you're thinking about this. Here's what we got. X squared minus 6x plus 8 is less than 0. Okay, not too hard in it. Give you 30 seconds, factor that out. So, with this, guys, we factor this and we get x minus 4 and x minus 2 less than 0. Well, let's find out when this graph is 0. When is this graph 0? Not graph because it's not a graph. Why is it not a graph? I should have said that better. Why is this not a graph? Anybody know? No. Why? You can't have a graph. Well, you could have a number line, right? Remember back in the day where there's like x is greater than 2, where you draw that on the number line? That's kind of what we are doing right now. We are doing that basically. That's what this is. Yeah, but still, like, so you have 4 and you have 2, right? So remember how your answer was saying, another way to write this was saying the interval that x is greater than 2 was 2 to infinity. That's another way to write it, correct? Of the interval that x was greater than 2. Or whatever that statement would have been, right? So in our statement we have this, so we're looking for the intervals that make this work. Because there's obviously more than just one number that makes this work. Because let's say, like, for example, I pick 5. Okay, if I pick 5, it's not going to work in here. There's a reason why. Number greater than 4, what do we get, people? Number greater than 4. There's 3, I wrote them out. Okay, so a million, we'll plug it in. What's a million minus 4? A million minus 2? Positive times positive. Okay, pick a number between 4 and 2. 3. 3 minus 4? Negative. 3 minus 2? Negative times positive. Good. Pick a number less than 2. I'm going to pick 0 because look, right there it's positive. My y-intercept is where 0 would be at, right? If that was a y-intercept, if I had a y there, correct? Alright. That's all I have to really, that's the hard part today, guys, right there. So now, I get my highlighter, and then I say to myself, so, what value, okay? What values are less than 0? Negative. Negative. That's the section that's negative. Right? So, what interval is that between 2 and 4? Include or not include? Okay, why is it not included? Okay, you have a straight voice today, kids. That was it. You're good. So, Amy, as you said, it's a less than. It's less than 0, correct? And these values are when the graph is 0. So, is 0 less than 0? No. So, that is the interval. Okay, that is the interval where the graph would be negative. Not graph, or the statement would be negative. Now, if there was a y there, okay, think about it. We could graph it and notice we have one, two. Well, we don't have to shade, but think about this. Where's that graph of our x's is greater than 0? Look, please. Oh, excuse me, we care about less than 0. Isn't that in between here? This graph is below value here. And that's in between 2 and 4, right? Other places, it was above it, right? Make sense? Well, I didn't shade. I'm not shading anything. But I'm looking for when this is less than 0. So, on the number line, if I had a y, this is what the graph would look like, right? But I want to know when it is less than 0. No, why? Doesn't that say stuff less than 0? I'm looking for stuff less than 0. And where's that at? In between 2. If I was looking for the stuff greater than 0, that'd be this section of the graph and this section of the graph. So if I was looking for greater than, that would be negative infinity up to 2, union that with 4 to infinity. Kind of like this. Well, it's not in the domain because we have no y value right. Because that is the section. So, okay, now think about an inequality. What does an inequality mean? Okay, if I gave you this x is greater than 2, how many answers are there that make that work? 6x plus 8 less than 0 are the only times you are in between 2 to 4. If I picked 5, notice what would it come out to be. Is that a true statement if I pick 5 then? How about if I pick 3? If I plug this in, would that make it a true statement? Yes. What if I pick 2.5? Would that be a true statement? Sure. What if I pick -1? Would that be a true statement? So I'm looking for the stuff or the interval for the x's that would make that equation, or I shouldn't say, it is an equation. That equation, or inequality I should say, work. So any number between 2 and 4, if I plug any number out of there into the equation for x, or inequality for x, that inequality should be true. This graph, who the hell cares? Okay, I was just trying to give you a visual representation of, notice looking here, Megan, we're looking for the graph less than 0. Well, here's 0 on the graph right there, right? Where's it less than? Here. And where's that in between? 2 and 4. Does that help you out more? The graph was just a visual representation, hopefully, too. Some people like visual graphs. I don't. I'm not a visual person. You know? I like me some math. It's around my own stuff. 2.7. Oh, just 2.7. We are reviewing Monday, testing Wednesday. Do we have a lot of tests on Wednesday? Or am I the first one? Monday. So we're reviewing. Okay. So last time we had it less than 0. This time we have it greater than -48. So I could kind of get a sketch and say, all right, let's graph this side over here, trying to figure out where is it greater than -48. Or what could I do? Get everything to the other side, and then I'm talking about where it's greater than or less than 0, right? So if I find the zeros, do my chart should be pretty easy, right? Everybody there with me? Add the 48. Because I want to be equal to 0. Because it's really easy to tell if something's greater than 0 or less than 0. That's pretty much telling you whether it's positive or negative, right? So that's why we want this side to get over the equal. I'm going to find zeros. I don't know if I can factor. Your sister has to help me. Very day. Okay, so then we're there. Is everybody okay with that? So now we're asking, when is this inequality greater than 0 now, right? Just be careful. Just be aware. What can happen if you divide or multiply by a negative in an inequality? What do you got to do? Flip the sign, right? Remember flipping the sign. Or multiply by a negative. Pay to both sides. Okay, so what are we going to do, guys? We got to find the zeros, because that'll tell us then our intervals that we need to work with, right? How are we going to find our zeros? From 2.5. Our rational zeros test, we can do that. I'm just telling you 48. Here's this rational zeros. You guys ready? This is a fun one. Plus or minus 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Divided by 1 and 2. That's fun! Is 1 a 0? How do you tell Garrett Mills? Plug it in for x, is that what you're saying? Or what's the rule that I showed you guys you could do? Add the coefficients, right? So what's 2 minus 3? Minus 32. Negative 33 plus the 48 does not get me there, but I'm at 1, 16. Okay? That might help me later, right? But can anybody see what you can do previously to what I showed you on 2.5? Clear it away. No longer. Sometimes we forget about looking at that choice, don't we? So now that we've learned this. Just to let you know, in A2 I didn't see that I could factor by grouping, and I was lucky. I picked 4 and it worked. My first shot. Had no idea. First shot. Well, obviously 1 was my first shot, but you get what I'm saying? I was like, okay, what does 2x cubed and 3x squared have in common?
Wait, how do you know you can't factorize?
Well, try it. That's really what it is. You have to look at it and say, are there something I can factor out of these two? Like, for example, negative 32 and 48 have in common. I don't know. That's 16 in common. And then notice that's 2x minus 3. And then notice plus 2x minus 3. Does everybody see that this is going to be x squared minus 16? And what does x squared minus 16 factor be, because it's called a difference of squares? X minus 4, x plus 4. Now once again, we want this greater than or equal to 0, right? On the one on your test is more likely to be looking for irrational people. Hopefully not 14. Right? Okay. Hopefully it's like 5. Okay, what's my zeros, ladies and gentlemen? 3 halves is one of them. 4 is one of them. Negative 4. We do our chart. That's what we do, guys. We get up there, we find our zeros, we do our chart, right? Is that important right now? I don't know. I don't think so. Okay, so what do we do now? You can pick up your phone, that's right. What? A million, right? 1 million. Let's do that green. 1 million. Let's do that green. 1 million. You're a good hippo. Positive, positive, positive. That is a positive. In between 3 halves and 4? 3. Positive, negative, positive. Yeah, everybody understand what I'm doing there? Some people last class had no idea. So what I'm doing technically is I'm taking a value in between here. So for me, example, a million, right? I plug it in for x. That's why I pick a million, because it's really easy to tell. 2 times a million, 2 million. Minus 3 is 1,999,997. A million minus 4. 999,996. I times those two. I don't know what that is, and I'm not going to. But you get what I'm saying. So the reason why I pick a million, it just takes away the thinking, right? That's 2 times a million. If I subtract 3 from it, that's still going to be positive. A million minus 4 is positive. A million plus 4 is positive. So if I have 3 positive numbers times together, I'm going to get a positive result, right? If I take 3, I'm plugging 3 in for x technically. 2 times 3. 6. 6 minus 3 is positive. 3 minus 4 is negative. 3 plus 4 is positive. I have 2 positives, 1 negative. And I times them together. What do I get? You know what that's for? Because look right here. I'm looking for stuff greater than 0. So am I looking for things that are positive or negative? Positive. I don't care about values. I'm looking for stuff that's positive or negative. That's it. So, pick a number between 3 halves and negative 4. It's really easy. I'm picking 0 and I go back up here and it is positive, because that's my y-intercept, right? If I had a y, that's kind of like my y-intercept, right? I picked 0 and I got positive. Or you could do it in here. Negative, negative, positive. That's that positive. Negative a million. 2 times negative a million is negative. A million minus 4 is negative. A million plus 4 is negative. 3 negatives, that is a negative. So, answering your question, Nikki, again, I am looking for this graph to come in greater than or equal to 0. Or this equation. I got to put the same graph. This equation greater than or equal to 0. So, Nikki, getting my highlighter out, what things are greater than or equal to 0? Not the number. Don't look at the number. That's not what I'm saying. When I plug a million in, is that result going to be greater than 0? That's what you got to ask yourself. Is the result when I plug these numbers in greater than 0? Okay? If I plug a million in or anything past 4, that stuff is going to be greater than 0, right? If I plug a number in between 3/2 and 4, is that information going to be greater than 0? The negative. Is the information between -4 and 3/2 going to give me a greater than 0? How about the stuff from -4 to -infinity? Is that stuff going to give me greater than 0? No. Okay, I'm looking for these sections because I'm looking for greater than or equal to 0. On our last problem, we were looking for things less than 0, so we were looking for the negative value. This is not yet it. This is going to help us. This is telling us the interval that it is. Now we're going to write it in interval notation. Okay? So this is telling us, yeah, this section in between here and here works. This section in between here and whoever works. That tells us that, right? That's what the chart tells us. Does that make sense? Okay? Without having to get so specific by picking numbers forever. Okay? So, now when I write it, what's the values that make it work? Okay. In between -4 and 3/2. Can I be, these were zeros, right? Correct? Can I be 0 in this one? Is 0 greater than or equal to 0? Sure is. So I'm including -4 to 3/2 bracket style. Right? Because I can be 0 this time because it's greater than or equal to. Right? Well, because I can be 0 this time, right? Parentheses, because that means that they go right up to that number, but you're not using that number. Because if I go to those numbers, that would be 0. And is 0 greater than 0? No. Is it equal to 0? Yes, that's what makes it work, right? That's what I'm saying, and that would be parentheses. So you cannot use those values because they would not work. So, and then my last section from 4 to can you ever touch infinity? Why is there breath from it? Because can I be 0? That 4 gives me a 0, right? Can I be 0 in that equation? What did it say on the end? Greater than or equal to, right? So therefore that's correct. Okay. So, what if we had something like this? I'm still an inequality equation, right? Type of deal. Do we like stuff on that other side being anything but 0? Okay. So therefore, I go ahead and do what? Add the 3. Are we okay with that? Anybody know what we need to do? I think of Arnold Schwarzenegger every time. The common denominator. Terminator. I don't know why I associate Terminator with denominator, but it is. Okay, that's what I do. Common denominator. Get used to it, people. That's what you do. X plus 1. So can I just put it on the bottom? Let's throw an X plus 1 down there. What we got to do? Put it on top as well. Everybody with me? Any concerns? Why? So I can get one ration. Have I showed you how to graph these things? No, they got to get one ration. Right? Does that make sense? So now I'm at 2x minus 1 over x plus 1 plus 3x plus 3 over x plus 1 is greater than or equal to 0. Now what can I do? Miss Holly. What can I do now? because now I have like denominators, I can combine the top, correct? So that becomes 5x minus plus 2 over x plus 1 greater than or equal to 0. Now, am I graphing? What was on my number chart when I did rational? Zeros was one of them. What else was on my number chart? No one remembers? Just zeros was on there? So in our case, negative 2/5. It was your vertical asymptote, right? Y in this case, that has nothing to do with 0. Why does this matter? I can't use that number, right? I cannot use negative 1. Correct? Can't use it. So because I can't use negative 1, I have to put it up there because it's kind of the interval saying, oh, I'm going to go from here to here, and so forth. Now, could you say I'm going from negative infinity up to negative 1 to negative 2/5? Sure, maybe that whole section was positive. In our case, that's what we're looking for, right? It's positive. But I still need to have him because I cannot be that number whatsoever. Correct? So we got to put him up there saying, you know what, guys? This guy gave me a 0, but this guy gave me undefined. Right? I can't use the undefined stuff. Okay. So, pick a number greater than 2/5. I'm going to pick 0 because notice it's right there. 2 over 1. Odd. It is 2 though. Okay. Number between negative 1 and negative 2/5. Negative a half. 5 times negative a half is negative 2.5 or negative 5 halves. Plus 2 is negative. Negative a half plus 1 is positive. So a negative over a positive is a... Is everybody clear on how I'm getting this? It is an important part. Okay? I might be going over it very quickly, but if you do not get it, please let me know. Yes? Any random number in between, and then plugging it in for x. And then telling me whether, when I'm simplified, it's going to be a positive or negative 1. Do I care what number that is? Just want to know positive or negative. Okay? Pick a number less than negative 1. Negative a million. That becomes a 5 times negative a million is negative, right? And a negative plus 1 is negative still. So a negative over a negative is a... What are we looking for? Are we looking for things that are greater than 0 or less than 0 rightly? So therefore, which two ones am I going to use? Let me get my highlighter. You tell me. Is it section number 1, 2, or 3? 1 and 3 in my sections, right? Because those are positive. And those things are greater than 0. Positives are greater than 0, right? Okay, so... Yep. I didn't. I highlighted. Highlight. Here, let me highlight better. Highlight. You're not using blue highlighters. Well, I don't know. Okay, so now, ladies and gentlemen, what we're going to do is find the interval. So I'm using this one. So what numbers am I using? Negative infinity up to negative 1. Now, was it greater than or equal to? What was it? Right? So was that include or not include? Not include. Why? Why is it a not include? Go, Amy, go, Amy, go! Go, Holly, go, Holly, go! It's a vertical asymptote, or it's a value I cannot be. So hence I cannot be it. Put a parenthesis on it. I cannot be him. Right? Inner math there, coming out right at you. Okay? What's the other part that works? Negative 2/5. Can we be him? Yes, that is a bracket, because he is a 0. And can I be 0? Yes, I can. Yes, ma'am. Yes, we are. Going to how hard? How hard? How high? Ladies and gentlemen, that right there would be an eagle. Is it really that cold? Cold? Oh, I just thought that's what you said. I'm just talking. No, I'm walking now. Now I hear you whining again.
Another example?
Oh, we got like 2 more. 3 more maybe. But this one's pretty fast. Can we factor? No. Factor's the one that gets you to -1? It ain't happening. Okay, so what do? Because those are still values that make it 0, is maybe through a quadratic such as an irrational, right? Such as 1 plus or minus root 3. Those are still zeros. Or x-intercepts, right? They still work. Okay, so let's get it out. Here we go. X equals... So that's 1 plus or minus the square root of b squared. That's 1 minus 4 times 1 times 1. All over 2 times 1. Still seem like telling you when I'm plugging them in. 1 plus or minus square root of -3, so that's I root 3 over 2. What does that tell me? Those are zeros, but are they x-intercepts? No. So even though this is not a graph, Megan, I'm still going to show you what it would kind of look like. So I'm never going to touch here, because that's what these would give me, right? If there was equal to y, or finding my y-intercept, right? Okay? So it's never going to touch here. What kind of graph is this? Allison, good job. It's going up, right? Looks like this. Where is this graph greater than 0? Everywhere. Well, how do we say everywhere? Negative, negative. Make sense? What if I said this graph was? Oh yeah. What if I said this? Okay, let's come down here. What if I said x squared plus 9? We should all understand what that graph should look like. You got your x squared, and then what does he do? Whoop! He shifts up 9, right? That my vertical was about 1.5 inches, I think. So that's pretty good. So this is basically the same graph up here, 9. Where's that graph less than 0? Or what is that equation? Less than never. And that should make sense because what's x squared? Always a positive number, right? And a positive number plus 9 is always a positive number. When is a positive number ever going to be less than 0? Never, so this is no solution. No real solution. Is there a solution that makes that work? Yeah, there are. There's no real solution. In this case, this would be no real solution for that guy. Not necessarily when there's no zeros. Because notice when I had no zeros and it was greater than 0 in our case, I had no x-intercepts. But I'm still saying, like, just because it doesn't necessarily mean it, you have to think about it. Is your graph or is your equation ever going to be greater than 0, or is it always greater than 0? When they don't have that, it's either or, right? They're always going to be positive or they're always going to be negative, and they never touch. It's quadratic. Does that answer your question? Last one. How is this part of our unit? How is that part of what we're doing today with polynomials and inequalities? If I'm asking you the domain of a square root, how do we connect this? Nikki? Sorry, I should have y equal 2. Good. Okay, so it's referring to the values of x that I can use in that equation, right? So, what? So, what? So that is going to mean. therefore, this is how it connects. Right? Just because I'm fat doesn't mean I'm not a little athletic. I apologize for my wrongdoing. What is this called, ladies and gentlemen? Difference of squares. So this goes into 7 minus 2x, 7 plus 2x. Everybody see where those happen? Oh, factory. So this is called the difference of squares. Notice what would you do with x squared minus 16? What does that factor be? Paid in only. X minus 4x plus 6. Still a difference of squares. Who? Anyway, finish this first. Alright, so, does that make sense? Okay. So notice therefore I'm at negative 7 halves and 7 halves. Pick a number greater than 7 halves. A million! And if I put a million here, that's negative 2 times a million, that's negative, right? What's this guy come out to be? Positive and negative times a positive is a negative. Do we want that region? No! Why? Because that's a negative and we want greater than. Pick a number in between negative 7 halves and 7 halves. 0. Come back up here. What does that mean? Positive. Do we like that region? Pick another one. Yes, ma'am. How do I know it's greater than or equal to 0? You just told me earlier it had to be a positive number. How do we write a positive number? Greater than or equal to 0, right? Greater than or equal to 0 means that I am positive. Okay, pick a negative a million. What? This guy? This guy? This guy? What guy are you talking about? How did I know it's greater than or equal to? What can square roots have to be underneath? Okay, pick negative a million. Positive negative, which is a negative. What works? What's the region that works? 2, 7 halves, right? Why is it brackets, Noah? I can be an equal to 0 and those values gave me 0, right? That was horrible. I'm not going to do this one, but I want you guys to think about this one as well. Yeah. That's not bad. That's the same idea. What does that mean? What do we do? It can't be negative again because it's a square root. So now you're taking a rational, and it's the same thing as we just did recently, right? So the thing is we're trying to find the domain of this, and because it's a square root, then we're right into there, right? Does that make sense to everyone? Now, is that any different than what I just showed you guys with a rational? It's that one step of taking the equation and asking the domain, then makes it into what we did today. I'm not ignoring. That's how this came about. Think about it, Nikki. Can I have the square root of negative 2? Can I have the square root of 16? Can I have the square root of negative 100? So what I'm saying by doing this is I'm taking this crap underneath the square root, and what does that crap always have to be? That's it. Okay, ladies and gentlemen, you are on 2-7. You're doing 1 through 53 odd. Every other odd, sorry. And then 55 through 59, you are doing